Physics, this is Mrs. Valletta. I'm going to make a quick movie to try to help you with a conservation of momentum problem. This is a problem that we really haven't gone over much in class. I've definitely gone over elastic, 2 remains 2. So that's when two objects collide and they stay two objects afterwards. And we've done two objects become one object. But this is our last example of conservation of momentum. And this is an example where we have two objects. So we have two objects, but they are acting as one. And then we're going to have an explosion and they're going to turn into two objects afterwards. So this is sort of a reverse inelastic collision. And what you'll see is that the formula for inelastic collisions for 1 becomes 2 is really just the inverse, or backwards, the 2 becomes 1. And so I'll show you what I mean. This is the initial momentum of the system. And the initial momentum of the system, the two objects are together. So we have the mass of the cannon. I'm going to call that mass 1. And we have the mass of the cannonball. So that's mass number 2. And they're acting together and they have an initial velocity together. And that initial velocity is 0. So if we take the two masses, the masses added together, this is actually 1 plus 2, is 1,010 kilograms, and we multiply it by the initial velocity, we get a momentum of 0 Newton seconds. Remember, momentum is kilograms times meters per second, or Newton seconds. Okay, that being true, if momentum is conserved, the initial momentum has to equal the final momentum. And that means if we add the momentum of these two objects, this is object number 1, with the momentum of object number 2, and they're traveling in opposite directions, so that's going to be important, that together they should equal the momentum of the system, which remember we've determined to be 0. Okay, so this prime, it means afterwards. So what's our momentum of object number 1 afterwards? Well, the object A here, it's got a velocity of 1.5 meters per second. Oh, I see they're using A and B rather than 1 and 2. Okay, I can fix that. Here's A and B and A and B. I usually think of objects 1 and 2, but that's fine. So object A has got a velocity of 1.5 meters per second. It has a mass of 1,000 kilograms. Remember, momentum is mass times velocity. And so its initial momentum is 1,500 Newton seconds, or 1,500 Newton seconds. Now look, we know they have to add up to 0. So the only thing that could add up to 0 when you have these two, is this would have to be a negative 1,500 Newton seconds. Remember, we said it would add up to 0. So P prime A plus P prime B, remember those are the after momentums, have to equal the initial momentum of A plus B. Right? So if you had something other than 0, you could just plug it into this equation and you could figure out what that final momentum is. But because they're at rest, it's easy, it's 0. All right, so now that we've done that, well, then we just need to, now that we know the momentum of object B, we're just missing its velocity. Remember, its momentum, so object B's final momentum is equal to its mass for object B times its final velocity for object B. We're missing the velocity, so we can plug in what we know. This is a negative 1,500 Newton seconds equals what its mass is, 10 kilograms. That hasn't changed. Times 10 kilograms times its velocity final. And when we solve for velocity final, what we get is a negative 150 meters per second. Now you might say, wow, are you sure about that? That's really fast. Well, yeah, I am sure about that, because if you look at the cannon, which is 100 times bigger, its velocity is exactly 100 times less. Okay, so remember, these are inelastic collisions. They're called 1 becomes 2. The formal equation, and you can add this to your four-corner activity. So if you wanted to add an equation to four-corner activity, it would be P initial 1 plus 2 is equal to P final for object 1 plus P final for object 2. And so the long equation would be mass 1 plus mass 2 times the initial velocity, and that's equal to mass 1 times its final velocity plus mass 2 times its final velocity. And because momentum is conserved, right, we have an equal sign. Hope that helps you do the problems. The answer to the problem set is online in case you are confused. Let me know if you have questions by sending me an email. Otherwise, I look forward to seeing pictures of your final work uploaded to Canvas or turned in with packet number 3. You can either have instantaneous gratification and let me grade it now, or you can grade it when we get back. Thanks, and talk to you soon.